Hey guys, welcome to another one of my videos. So today we're going to be tackling a work problem that you may encounter in Calculus 2 or a physics class. So the problem here states that a painter weighing 120 pounds is hoisted by means of a rope, windlass from the ground to a window on the 10th story of a hotel, 80 feet from the ground level. So the first question posed is, if the weight of the entire rope is considered to be negligible, then find the work W required to lift the person to 80 feet from the ground level. And then the second question assumes that instead the rope has a substantial chain weighing 2 pounds per foot, and it's used in the windlass. And and it's asking to find the work required to lift the person the 80 feet from the ground level as well. So let's start with question A, right? Let's find the work done if the weight of the rope is negligible. Okay, so the first thing that I'm going to do is I'm going to draw myself a nice picture. So here's my picture. So here I have my ground level, and then I'm going to have building, right? Just like that. Just like that. Okay, good enough building with the window up here. And we have this person, right? And I'm going to draw this person as just like a ball, okay? And we know that this guy weighs 120 pounds, so that's his weight force. And then we have some kind of chain pulling it up, right? So, attacking the first problem, it's saying that the weight of the chain is negligible. So we're going to have to first state a few things. The first thing we have to know is that work equals the integral from some bound to some bound of f of x dx, and the f of x dx, the f of x is the force. So to gain some understanding into what and how this came about, physically, we know that the work equals the force times the distance, right? So essentially, you're basically just integrating the force from A to B, which is your distance. So that's how we get this formula. So just know that work equals the integral from A to B of the force dx, right? So what is our first step? Our first step is we need to find what f of x is, okay? Or the force is. So in this case, the only force that we have, so we have this rope pulling up, right? And we have this 120-pound weight force from the painter. And that's really the only force present, because this rope, right? I didn't mean to circle it like that, but this rope right here, right, has negligible mass, so it does not matter. So the only force is 120-pound force acting downwards, which is just the weight of the painter. So we can say that our f of x, or our force, equals just 120 pounds, right? So force. And following this, now we can use all of this to understand that our work will just be the integral from, so we need to find our bounds now. What is A and what is B? So A equals 0 because this is ground level. And then we have our window up here, right? Which is 80 feet. So let's just do this. 80 feet, right? As they say in the problem, 80 feet from ground level. So B equals 80. And that is window height. Okay, so now we're just going to integrate from 0 to 80 then of 120 dx, because we're literally just putting in this 120-pound f of x into right here, right? So that's how we get it right there. So is this 120 dx? And we'll simply just integrate this. And when we integrate this, it's just the antiderivative is 120x from 0 to 80. So it's just 120 times 80 minus 120 times 0. So the work done equals 9,600 foot-pounds. 9,600 foot-pounds. There we go. So that is the work done if the weight of the rope is negligible. Now the tricky part. The second question poses a little difficulty, saying that what does it say? It says a substantial chain weighing 2 pounds per foot. So 2 pounds per foot. Okay, understanding this, we have to know that the weight of the chain, right, is 2 pounds every feet. So as the footage, or I guess footage, right? Yeah, the footage or the length of the chain changes, so does the weight of the chain. So we must come up with some formula, right, for chain weight, because that will provide a necessary force that we need to incorporate into our work integration, right? So the chain weight equals what? Some sort of formula we need to figure out. So we know that it's 2 pounds for every feet. And our person, right? Our person, the circle, is going from 0 feet to 80 feet, right? So the max length of our rope is when it's in the starting position, right? Because it's the lowest, it's going to be 80 feet long. So the length of the chain equals 80 feet at our lowest point. And the top point, the length of the chain should essentially equal 0 feet, right? Because it's already reached the top. The chain is pulled all the way up. So it should be 0 feet or 0 length of chain left. So the formula that we can come up with is that chain weight equals 2 times 80 minus x. That is because 80 is max length, and every movement will just be changed by x, right? So if we want to see this logically, if I want to know the chain weight when the chain is 80 feet long, it's just going to be 2 times 80 minus 0. So the 0, because this is our starting position, right? So at our starting position, it's 160 pounds. And then at our finishing position, the painter has moved up to 80 feet. So you do 80 minus 80, and then so you get 0 pounds right there, right? So now we're going to move on to our force equation. So our force, what is it going to equal, right? So we have to find what that is. So what is our force going to be? So our force is going to be first the weight of that painter. So it doesn't change from before. So weight of painter. The painter is always still there. So the weight of painter has to be incorporated into our force. So 120 pounds plus the chain weight, which is, we figured out as 2. I'm just going to do this. Figure it out as 2 times 80 minus x. So from here, I'm going to label this as chain weight. And if I want to find the work done here, the work done is going to be equal to the integral from 0 to 80 again, okay, because it doesn't change. It starts from ground level and go all the way to the 80 foot up. So 0 to 80, and then we're literally just going to plug this force in because we know that weight equals the integral of force. So we're going to plug this guy in right here and then tack on a dx right here. So now we're just going to integrate this. I'm not going to go into depth on how I integrate it, but the antiderivative is going to be, let's do this first. Let's simplify first. So 120 plus 160 minus 2x dx, and that equals integral of 280 minus 2x dx. And then the antiderivative of all that is 280x minus x squared. And then it's just like this, the bound from 0 to 80, evaluate, so 280 minus 80 minus 80 squared minus 280 times 0 minus 0 squared. And all of that just equals 0, so this cancels out. And so now you're just left with 280 times 80. So that's just 22,400, I believe. And then 80 squared is 6,400. So if you subtract that, the work done equals 16,000 foot-pounds. Boom. And there we go. That's our work done. So that's how you approach a work problem with some kind of, someone being hoisted up to some kind of building or something like that. And when approaching these problems, when the length of the weight of the rope is negligible, it's just going to be the weight of the person, right? Because that's the only force that's present. So like part A is very self-explanatory, and there's only 120 pounds of force acting down, which is the weight force of the painter. So you just integrate that from 0 to 80, which is our bound, and you get 9,600 foot-pounds, and you don't really have to account for the weight of the chain. But in part B, they say that the weight of the chain changes as 2 pounds per foot. So you have to account for that. And to do that, you need to find some sort of formula that relates chain weight to the change in position of the painter, right? So after you figure that out, you can just add that to the original weight of the painter, and that will give you the force equation, and then integrate all that and find the work from there. So that's how you do a work problem like this, and I wish you the best of luck, and thank you for watching my video. Bye-bye.